Uh, Hi guys, my name is Talming and Touch and my Matrix ID number is AA201143 and my lab partner for this assignment is Kuban Rashpativan and his Matrix ID is AA201316. So without any further ado, we're going to jump into our lab 1 which is TC Moto. So as you can see, I've already completed this model and we're going to need 6 gain blocks for it and two addition block for this and two integral blocks for this. As you can see, all those triangles are the gain blocks, and this block which is 1 over s is our integrator block, and these two our addition blocks, and this would be our input one which is voltage, and right here it would be speed which is our output. So I'm going to explain all the functions of it. So the addition block utilized in these simulations are used to implement addition and subtractions on their inputs, which in this MATLAB simulation are resistance, voltage, and key are connected to the addition 1 blocks. As you can see, the resistance is connected to the negative symbol of the add block, and while the our input, which is our the voltage, is connected to the positive signal. So how we're going to change the signals during the process of creating this model? So you just have to double click it and put in the symbols that we want. Same goes to this add block, but as you can see, there's a KT and damping are connected to this block, and it only has two symbols. And it will the addition block will carry out the operation based on its symbol to which they are related to. Then the input is multiplied by the gain. These are the gain by a constant value using the gain blocks law. So the gain block calculates its gain in the simulation using the command window, which includes the G, B, K, E, K, T, R, and the L. So how we're gonna put it into the gain block? So you just have to double click it and put in our variable there. And to name it, you just click it below that and name. It depends on the symbol. So for R, it's resistance, and for this gain, it's actually our inductance. So I've named it 1 over L. And this is for our inertia, so I've named it 1 over G. Double click and put in the variable do you want and just click OK. So what we're going to do now, so for all the variables you have to specify all those variables. So for that you need to go to the model properties, and we're going to click callback, and we're going to put in the constant values. For the J it's 0.01, B equals to 0.1, K equals to 0.01, R equals to 1, and L equals to 0.5. Just gonna click OK. So now we're gonna create a subsystem. So for that, we're just gonna highlight everything, right click, and we're gonna click this create subsystem for the selection. So if you do that, we're gonna end up right like here. So this is our actual subsystem. So we're gonna name our subsystem as EC. So after that, like you have to change the time to 5 from 10 to 5, and we're gonna add in our final value, which is our desired value. So first we're gonna we're gonna add in the value 1. So 1 is actually our desired response. So what is that? We're gonna double click the scope and it will show us the graph, which is the actual value. So you can see that actual value is 0.1 for the desired response 1. So we're gonna repeat it 9 more times for our 9 more values. So we're just going to double click the step and put in our second desired value, which is 2, and run the simulation. Double click it again, and you can see the graph shows 0.2. And we're just going to repeat this process again and again until the desired outcome, which is 50. So we're just going to double click 3 and run. So now you can see that for the desired response 3, the actual value is actually 0.3. So we're going to do it for the desired response 4. Run the simulation again, double click the scope, and you're gonna get the graph again. And now I'm going to jump into the, the final step, really 20. I'm skipping some of the steps because it's just a repeating process. So 20, run, scope shows 2. And for 50, okay, the scope, I'm sorry, I forgot to run. It would show 5. So why is this happening? So for the desired response 50, we did get 5. For the desired response of 1, we did get 0.1. This is due to the percentage error that happening in the system. For the percentage error, the main key is the desired response and the actual response. And the formula is desired response minus actual response over desired response times by 100, and we would get the percentage error. As you can see, I've done the lab sheet out here, and I'm going to show you all those 10 graphs together. So this is the graph 1, graph 2, graph 3, graph 4. These are all our graphs that are obtained from that. So as you can see, the percentage error is the difference between the desired and the actual value in comparison to the value, and it's expressed as a percentage. So due to this disturbance, we did not get the actual, did not meet our desired response. So actually our actual response should be supposed to be as equal as the desired response, and we did not match that because of the percentage error. And that's all from me. Thank you.